Welcome back to College Algebra, Unit 6, Lesson 3, Properties of Trigonometric Functions. This is day 3 of 4. In day 2, we talked about some identities for trigonometric functions, including the reciprocal identities and quotient identities. There's also a set called the Pythagorean Identities, and they're called Pythagorean because of the Pythagorean Theorem. And there are 3 of them. The one that's used most often is cosine squared plus sine squared equals 1. If we took cosine squared plus sine squared equals 1 and divided everything by sine squared theta, we would get this second identity, which is cotangent squared plus 1 equals cosecant squared. And if we took the first identity and divided by cosine squared, we would get the third identity, which is 1 plus tangent squared theta is equal to secant squared theta. Often the second and third identities can be solved so they're equal to 1. We could have cosecant squared theta minus cotangent squared theta equals 1. And we could have secant squared theta minus tangent squared theta equals 1. So for our first set of examples, we're going to find the exact value of a trigonometric expression using any of those identities, the reciprocal identities, the quotient identities, or the Pythagorean identities. Find the exact value of each expression. Do not use a calculator. So for the first example, tangent of 20 degrees minus sine of 20 divided by cosine of 20. If we look at, because we have division of two trigonometric functions, we could look at the quotient identities and see that sine of an angle divided by cosine of an angle is equal to the tangent of that angle. And so I have tangent of 20 degrees minus tangent of 20 degrees. Something minus itself is equal to 0. On the second example, sine squared pi over 12 plus 1 over secant squared pi over 12. Well, 1 over secant squared would be the same as 1 divided by secant squared. And then I can use my reciprocal identities. Secant is 1 over cosine, and it's being squared. So that's going to be 1 over cosine squared pi over 12. And so if I change division to multiplication of the reciprocal, this would be then cosine squared pi over 12 over 1. And we would end up with sine squared pi over 12 plus cosine squared pi over 12. And again, this is one of our identities. Sine squared of an angle plus cosine squared of an angle is equal to 1. the last type of property we're going to talk about today is the odd and even properties. For trigonometric, for any function, an odd function says if you take that function at the opposite of x, you get the opposite of that function at x. So with trig functions, like sine is an odd function because if I take sine of negative theta, that's the same as the opposite of sine theta. Tangent of negative theta is the opposite of tangent theta. Cosecant of negative theta is the opposite of cosecant theta. And cotangent of the opposite of theta is equal to the opposite of cotangent theta. Even functions, if I take the, in this case, cosine would be an even trigonometric function. Cosine of the opposite of theta is the same thing as if I just took cosine of theta and ignored the negative. So even functions are maybe a little bit easier to work with. Secant is also an even function. Secant of the opposite of theta is the same as secant of theta. So the way we'll go about using these, finding the exact value using odd or even properties. Find the exact value of sine of negative 45 degrees. Again, sine is an odd function, so this is going to be the same as the opposite of sine at 45 degrees. And from our unit circle, we know the sine of 45 degrees is the square root of 2 over 2, and we take the opposite of that. Cosine of the opposite of pi is going to be the exact same as cosine of pi. And cosine of pi, again from our unit circle, is negative 1. Cotangent of the opposite of 3 pi over 2. Cotangent is an odd function, so we're going to get the opposite of cotangent, 3 pi over 2. Cotangent is cosine over sine, so at 3 pi over 2, we would get 0 over negative 1 for a value of 0. Finally, we have tangent of the opposite of 37 pi over 4. Again, tangent is odd, so we get the opposite of tangent, 37 pi over 4. And now we're going to use the fact that tangent is has a period of pi, so we can remove full factors of pi. So this is going to be the opposite of tangent. 37 pi over 4 would be the same as pi over 4 plus 36 pi over 4. So this pi over 4 is like 1 pi over 4. 36 pi over 4 is the same as 9 pi. And so I can ignore that part. And so I get the opposite of tangent pi over 4. Tangent of pi over 4 would be sine of pi over 4 divided by cosine of pi over 4, which is 1. and then I take the opposite. So your assignment will be on Schoology, dealing with the odd and even properties and the identities of trigonometric functions.